Hi, my name is Zach Niazi. I'm the founder and CEO of Circle Optics. At Circle, we've developed the world's first stitch-free 360-degree camera. 360-degree video can be live streamed to provide greater situational awareness for our first responders. The challenge with 360 video today is that live streams have errors like these baked in due to perspective differences between adjacent cameras. These errors need to be corrected through a manually intensive process called stitching. Imagine Photoshop, but much worse. At Circle, we've invented the world's first stitch-free 360 camera by developing novel lenses where the perspectives don't differ between adjacent cameras, but rather combine to produce a panoramic image free of any distortion. Here are 360-degree panoramas captured at the speed of light using our technology. These images were captured at our office in Rochester, New York. There was no post-processing applied to this imagery whatsoever. All of these images were stitched at the level of the lenses themselves, producing artifact-free imagery at the speed of light. And here you can see one of those same equirectangular photos when viewed through a 360-degree photo viewing app. The images in the previous slide were what's called equirectangular, which is a way of projecting a 360-degree image onto a flat 2D plane. That input data can be viewed through a 360 photo viewer app like this to see the image on a desktop application. And it can also be viewed through a virtual reality headset such as an Oculus Rift. This technique of blending together multiple 360-degree images separated physically is called spherical photogrammetry. And it can be used to create a 3D model of a space that has higher accuracy and requires less processing than photogrammetry using 2D photos. The reason that 360 photos are a better input data source is that because 360-degree photos cover every direction, the registration of one 360 photo to another is faster and more accurate than when matching multiple 2D pictures together. The closest competitive offering to ours is the Civetta 360 camera, which pivots a camera about a no parallax point to collect a stitch-free image once every few minutes. For first responder applications, the use of this technology is impractical when compared to our 360 solution, which captures 60 frames every second. With our phase 1 prize money, we began experimenting with taking 360 images produced with our camera and running them through 3D modeling software called Agisoft Metashape. Here are some of the results. With no user oversight and minimal compute processing, we were able to generate a 3D model with 2-meter voxel accuracy, as determined by the model's mean reprojection error. A voxel is a 3-dimensional pixel. Less than half of the pixel data from the input images was registered in the 3D model. While this is nearly acceptable for the purposes of tracking a first responder to 1-meter accuracy, we believe that much better accuracy is attainable. In subsequent phases, we aim to get the error down to 6 inches mean RMS error, along with getting better than 90% pixel registration, which will lead to more photorealistic 3D models like seen here. We'll improve accuracy by adding telemetry data from a 450 megahertz IMU. Additionally, we've developed an auto exposure algorithm that will clean up images, greatly enhancing accuracy by making illumination levels more consistent frame to frame. We've also begun experimenting with algorithms that denoise imagery using AI and believe that this could help us attain higher accuracy in the next phase. Here's an example of such a denoising algorithm tested during phase 1. The eventual solution we envision for our first responder partners is a drone-mounted solution weighing less than 3 pounds. We just began a $1 million effort with the National Science Foundation to develop this system for lightweight drones. With a drone moving quickly throughout a space, we could generate a 3D model by beaming the data over to a local computer via 5G signal. Our solution can generate this model more efficiently and with higher accuracy than any other camera-based solution. As a result, we believe that it's going to be a game changer for the first responder market. Thank you so much for your time, and we thank you for allowing us to participate in the first responder competition.